So a rolling memory buffer is the most common and straightforward technique used to manage the overflow problem of a context window. So rolling memory buffers, they are the most common and straightforward technique to manage overflow problem of a context window. So we all are aware of the overflow problem of a context window. So the idea is that the size of the context window is fixed, and during the long interaction, like as we keep on adding more and more data to the context window, after a point of time, it will start getting overflowed. And in that scenario, we have to make room for more incoming data. And that is what managing the overflow problem means. Making room for incoming data, making room in the context window. So rolling memory buffer is a technique to manage the overflow problem of a context window. So in rolling memory buffer, we make use of the sliding window approach. So this sliding window approach, it ensures the agent always hit like has the most immediate context available. So sliding window approach ensures the most immediate context is made available to the agent without crashing the system or exceeding the token limits. So without crashing the system and exceeding the token limits, sliding window approach ensures that the agent has access to the most immediate context available. So here we can get an idea about it. Like let us suppose we have a full context. Like it is like a full context window, and sliding window approach. The idea is that it will focus on the immediate context, like the most immediate context available. So sliding window is focusing on that. So sliding window, if we talk about sliding window approach, so we are talking about rolling memory buffers. Rolling memory buffers is basically the most common and straightforward technique to manage overflow problems of a context window. It follows the sliding window approach, wherein the idea is that the most immediate context available is made available to the agent, and hence it prevents the crashing of the system or token limit exceeding the token limits. Now let us go like get deep and understand clearly how exactly rolling memory buffer works. So if in order to understand the working of rolling memory buffers, we have to consider the FIFO principle. So FIFO is the first in, first out. So FIFO principle is the first in, first out principle. So the idea is that whosoever gets first in the context window will be the first to be thrown out. So let us understand it with an example. So here we have a fixed size context window. We have a fixed size context window. As you can see, initially this context window was empty. Then message 1 appeared. Then message 2, message 3, message 4, like that. And after a point of time, this fixed size context window will get full. And now once it is full, any new incoming message, it will not be able to accommodate in this fixed context window because there is no room for it. We have to make room for it. So in order to make room for it, what we will do is that we will flush out the oldest message. So that is the FIFO principle, first in, first out. Whosoever entered this buffer first will be the first to be thrown out. So message 1 will be thrown out first, then message 2, message 3, like that. And the new messages will be pushed into the fixed buffer size. Here we are taking a buffer size of 10 messages. So this buffer can accommodate up to 10 message. So as 11th message tries to enter the buffer, the oldest message will be flushed out of the buffer, fixed buffer size. So that is the FIFO principle, first in, first out. So rolling memory buffer, it also follows the FIFO principle. So here the idea is that you send a message, any new incoming message, it gets added to the buffer. The agent response, that's added to the buffer. And once the buffer hits its limit, like 10 messages, like here we are taking an example of a fixed buffer size which can accommodate 10 messages. So once the buffer hits its limit, the very first message of the conversation is deleted. So once the limit is reached, we have to make room for new message to get accommodated in the buffer. So message 1 will get deleted. Once the buffer limit is reached, the oldest message will get deleted from this fixed buffer size. And once the oldest message gets deleted, there will be a room for the new incoming message, and that we will add. So the next message here will be added, and let us suppose now message 12 wants to enter the buffer. So message 2 will be flushed out, and message 13 wants to enter. So message 3, the oldest message, will be flushed out of the buffer to make room for the message 13. So this is what is rolling memory buffer is. So here the memory buffer is getting rolled. How it is rolling is that oldest messages are getting flushed out of the buffer, and the new messages are getting added to the buffer. So this is how the rolling memory buffer works. It follows the first in, first out principle. So in rolling memory buffers, we have two types of buffers. So we can make use of two types of buffers. So the first one is the message count buffer. So in message count buffer, the rule is to just keep only the last 10 messages. Like the latest 10 messages, we just have to keep that, and all the old messages we will delete it from the buffer. So that is the message count buffer. So in message count buffer, we are counting the number of messages, and based on that, we are deciding when to flush out the old messages. And message count buffer, it is very easy to implement. If one message is an entire 50-page PDF, now we will discuss the cons of it, the disadvantage of message count buffer. Now see, message count buffer, it is just keeping track of the number of messages and not the size of the message. Just imagine I have one very, very big message. Like if one message is an entire 50-page PDF, then that one message can completely occupy the entire buffer. And that one message could blow the context window, even if you only keep two messages in the buffer. Because based on the message count buffer, it will just count the number of messages, and it will not at all look at the size of the message, the length of the message. And the idea is that if I have a very big message, that message might occupy more than 80% of the buffer, and despite of having just two messages, our buffer can get filled, and hence the rule will not be followed, because according to the rule, flushing will be done after 10 messages, and here with only two messages the buffer got filled, and hence no flushing will be done. And message count buffer, this is a like a very big drawback of the message count buffer. Similarly, we have token limit buffer. Like we are discussing the two types of buffers. So token limit buffer is like a one of the kind of a buffer, rolling memory buffer. So in token limit buffer, we decide the flushing based on the number of tokens. So like it follows a rule like keep the last 4,000 tokens. So this is a rule. So if I have a rolling memory buffer, if it follows this rule, so the idea is that it will hold the latest 4,000 tokens, and all the old tokens, the previous tokens, it will flush it out from the buffer. So that is the idea of token limit buffer. Now this token limit buffer, definitely it is much safer for technical stability. It precisely manages the real estate of the model's brain. See, the good thing about uh, token limit buffer is that it is not counting the number of messages, rather it is counting the number of tokens. So the advantage is that, let us suppose I have a very big message, that also it can handle. So it is just looking at the number of tokens, and if the number of tokens exceeds its limit, it will flush out the old tokens to make room for the new tokens. So that is the token limit buffer. So token limit buffer, it is a rolling memory buffer based on the token limits. It will keep a count on the number of tokens. Now it has one drawback. So the drawback of token limit buffer is that it may cut off a message in the middle of a sentence if the token limit is reached. If the token limit is reached, it will cut off a message in the middle of a sentence. So see, the idea is that, let us suppose we are filling the buffer, and in the middle of a message that the buffer got filled. Then what will happen is that when we are flushing out to make room, it might happen that instead of flushing out the entire message, we are just flushing out 50% of the message. Like 50% of the message is outside the buffer, it got flushed out, and 50% incomplete message is the part of the buffer. That might happen. And incomplete message is always dangerous, because we know that whatever is there in the context window, that will be the part of the active short-term memory, and large language model will process it. And if large language model is processing an incomplete information, that can be very dangerous, because incomplete information, it can be very, very dangerous. So that's a very big drawback of token limit buffer, wherein because it is not at all looking at the messages, it is just counting the tokens. And there might be scenarios wherein we might end up having incomplete messages or incomplete information in the context window, because some of the tokens of those messages might be flushed out to make room for the new tokens. So this is a very big limitation of a token limit buffer. Now let us discuss the major benefits of rolling memory buffer. Major benefits of rolling memory buffers. So speed and latency. So because of the rolling memory buffers, we are taking care of the buffer overflow or the context window overflow problem. And because of that, we are able to achieve consistent prompt size. And because the prompt size stays consistent, it never grows past the buffer limit. And because of the fixed prompt size, the model's response time remains fast and predictable. Now, the second benefit of rolling memory buffers is the cost control. Since you are not sending a massive, ever growing history with every turn, you save significantly on API cost. Because of rolling memory buffers, we can just fix the buffer size. We can fix the size of the context window, and inside context window also we can fix the buffer size. So because of that fixed buffer size, we can significantly save API costing, API pricing, API charges. Third major benefit you will get because of rolling memory buffers is the simplicity. Now see, rolling memory buffers, It is just based on the principle of FIFO, first in, first out. So the implementation of rolling memory buffers is very simple. Rolling memory buffers, it requires no complex database or external search like the RAG, retrieval augmentation generation. Rolling memory buffers, if we talk about, it is just a simple list or array in code. So we are implementing the buffer in the form of a list or array, fixed size list or array. So it is very easy to implement rolling memory buffers. And because of this rolling memory buffers, we can achieve speed, latency, we can take care of latency, we can do the cost control, and implementation of rolling memory buffer is very simple. No need for complex database like vector database or no need for RAG. The implementation makes use of just a simple list or array in code. The goldfish limitation. Now we will discuss the goldfish limitation. So the biggest drawback is the loss of long-term continuity. So the biggest drawback of rolling memory buffer is that the oldest messages, they are getting wiped off from the context window. And in the long run, we will see that there will be the loss of long-term continuity. The agent will start forgetting because agent remembers whatever is there in the context window. We know that large language model is stateless. Large language model is stateless. Large language model does not, it cannot remember. So it can remember only whatever is there in the context window. So context window acts like an active short-term memory for a large language model. Now, context window size is fixed. It is limited. So in the long interaction, we have to wipe out the oldest messages to make room for new messages. Because of that, we will see that agent will start forgetting the old interactions, and hence we will like we can see the loss of long-term continuity. And that is what is the goldfish limitation is. Like here we can see this is the active context window. Now it is the active context window. Now definitely to make room for new messages like the message number 20, to make room for it, we have to wipe out message number 1. Like that, to make room for the new message, we have to wipe out the subsequent old messages. And since it is removed from the active context window, active memory window, those interactions are forgotten or rolled off. And this active memory window is also called as goldfish view. This active memory window is also called as goldfish view, and hence it is called as goldfish limitation. Like whatever is there in the goldfish view, only that can be taken into consideration by the large language model. Large language model will remember only the things present in the active memory window or the goldfish view. All the messages which are wiped out, the old interactions, that will be forgotten by the large language model. So rolling memory buffer, it acts like a conveyor belt. So rolling memory buffer, it acts like a conveyor belt. So the idea is that we have a fixed goldfish view, and the conveyor, because of the conveyor belt, these messages will stay in the goldfish view for a certain time because the conveyor belt is moving. So with time, these messages will be flushed out. Like message number 15, 16, 17, 18, 19, it will be flushed out of the active memory window, and new messages will occupy the active memory window. So the biggest drawback of the rolling memory buffer, because the rolling memory buffer is acting like a conveyor belt, so the old interactions will be wiped off of the buffer. So there will be a loss of long-term continuity. The instructions has rolled off, and the consequence of it will be agent feels smart in the moment but forgetful over long projects. So initially agent will feel very smart because whatever is there in the active memory window, agent is totally aware of that. But once in the long run, those information will be wiped off, and we will see that agent will become forgetful over long projects. So that is what the goldfish limitation is. When to use a rolling memory buffer? When to use a rolling memory buffer? So see, if we talk about rolling memory buffers, they are perfect for short transactional chats. So for short transactional chats, rolling memory buffer are very good. For example, for customer support, because customer support is like a very short term chat. Like you ordered something, there was some issue, so you went for a customer support, and the interaction will be in the short run. So there you can use rolling memory buffer. So for short transactional chats like customer support with coding fix, you can go for rolling memory buffers. But they are not at all sufficient for AI executive assistant needing long-term memory months. Like let us suppose you are making use of an AI agent, you're giving it a role, like act like a personal assistant, act like my personal assistant, act like a senior software engineer. So if you are giving an AI agent a role, in that scenario, the AI agent has to remember, it has to have the long-term memory, like the months and the years of the memory it should hold. Because then the interaction, the responses has to do with the old interactions as well. The response of the large language model has to do with the user preferences. So there, rolling memory buffer is not sufficient because rolling memory buffer is like a short term. It is like an active context window. So we will be needing a long term memory. So now it's very clear that if you just want short transactional chats like customer support, quick coding fix, their rolling memory buffer you can make use. But if you are looking for an AI agent which will be acting like a personal assistant or project manager, then their rolling memory buffer is not sufficient. We have to make use of long term memory as well because we have to store the months of data, years of data in the memory. Now let us see how we can fix the goldfish problem. Fixing the goldfish problem. So we already saw that rolling memory buffers, they act like a conveyor belt wherein the goldfish view is a fixed view. It is the active context window. Now what is happening is that the messages, they are getting stored in the active context window, but the conveyor belt is moving. So the idea is that those messages will get wiped off and the new incoming messages will take their place in the active context window. And because of that, the agent, it starts forgetting the old interactions, and that is what the goldfish problem is. Now how we can resolve that problem is that definitely we will be making use of the rolling memory buffer, the conveyor belt. Now what we will do is that when we are wiping it out, like when we are wiping out the old messages, rather than just throwing it out completely, we will take those old messages, summarize it, condense it, and the condensed form, once again, we will be putting it in the active context window. So the recap at the top of the window, we will put it summary. So whatever messages we are wiping out of the active context window, we will summarize those particular messages and the summary of it, which will be like a very highly condensed version, that we will put back to the rolling memory buffer. So in this way, the agent will not forget everything because a very relevant context still be there, still be the part of the active context window. And hence we will be able to fix the goldfish problem. So we are combining the rolling buffers with some summary memory where instead of just dropping out the old messages, the agent writes a quick recap of what happened and keeps that at the top of the window. So that's the main idea. Like combine the rolling buffer with summary memory of the messages which we are about to wipe off, and it will retain the key context.